Hello, and welcome to my series on reloading light loads for the 375 Holland & Holland using cast bullets. This is a project I've undertaken because I enjoy shooting my 375 Holland & Holland and my CZ550 American Safari, but I want to do so at a much lower price with much less recoil. And cast bullets are the best way to go for reduced loads. I also harvest my own lead out of my own berms, so my cost of lead is free. So I can shoot my rifle for around 7 to 10 cents a load using light loads, and under 20 cents using full charge loads using slower burning gunpowders. This series will be about developing loads using shotgun and pistol powders for light economy loads. If you buy your cast bullets for these projects, you may go with what is cheapest. And for me, I also consider the castability of the bullets. This is a very fine bullet. I've shot a deer with it in 2016. I have a video on that. However, it is in a single cavity Lyman mold, so it takes a long period of time to produce a good quantity of bullets, although they are very high quality and have potential for accuracy. So we will not be using that for the first part of the tests. The plain-based bullet I have cast from the Lee mold is potentially perfect for this project. However, I am not a fan of casting with aluminum blocks. So for this part of the project, we're going to also put that to the side. And for this project, I'm going to choose the Lyman 375-449. Although it has a cut heel for a gas check, which may present problems with many loads if we're going to save money by not putting on a gas check. If we do eventually put on a gas check, we can send this bullet at a much higher velocity with much softer alloys without worry. And I have chosen it because I can cast from a double steel mold, which works very well. And I have a quantity of these already produced and lubed, so I'm going to simply start the project using them. I believe that the bullets I've cast from steel blocks are of superior quality to anything I've produced in aluminum, so I think this is a fine place to start. The purpose of this load is a pure fun plinker at low price and low recoil. Therefore, we are going to focus on loads for this bullet using fast-burning shotgun and pistol powders. Now that we have our load set, we can proceed. Now that we have a cartridge and a bullet selected and a range of velocity and powders we want to use, we should first start, of course, at our official resources from the official publishers of powder and bullet making. So we turn to our Lyman books. Now Lyman 4 has some very good information on the exact bullet we are going to use. However, it only lists for modern slow burning powders such as Reloader 7 and IMR 4198. Now if we were going to make a hunting load at high velocity, this would be a very good resource for us, of course. However, our project is not to create a high velocity round, and we want to use a faster burning powder with smaller charges to save money. So our venerable 4th edition is not very valuable to us in this project. This is where the older manuals are quite worth the money. Lyman's 3rd edition does list a lot of shotgun and handgun powders. Unfortunately, this does not list the exact bullet we are using, which is a problem that some reloaders may come across. And the general rule of thumb that's been offered is if you do not have an exact load for your particular bullet, try to go for one that is at the same weight, or take a bullet that is heavier, lead bullet, and then use its powder charges if you have a lighter bullet. Bigger bullets require less powder to get the same amount of sheer energy, and also you will reach your maximum pressure with smaller amounts of the same gunpowders with heavier bullets in general. So therefore, that rule of thumb can be applied. If we cannot find a lead cast bullet of similar weight, we're simply going to find one of superior weight and work up from the powder charges suggested. This did have a bullet that was quite near what our bullet is in size and weight, although not the exact same bullet. And so for this project, we will simply use that information without displaying too much of a page from a different reloading book to get into copyright trouble. This is a good example of what the load list should look like. Now this is for a Lyman bullet that is about 15 grains lighter, but still offers the kind of information you're going to see. Various powders, starting and maximum loads, and suggested velocities. Now the Lyman 3rd edition suggests powder charges that are about a half a grain lighter than what this bullet is listed at. So this is not the exact same that we are going to work from. Now that we've got a list of potential loads, we'll look down the list of powders and see what we have in our own personal stock and what we like to use. Red Dot has had an excellent service history, and many light cast plinkers will swear by it for rifle cast loads. So we'll choose Red Dot first. We'll also choose Green Dot and Unique later on. Unique also having a long, successful history with cast rifle loads, especially more moderate loads for pistol and shotgun powders. Since I have 20 cases dedicated to cast rifle shooting with my 375, what I do when working up a load, once I have my powder selected, is to take my 20 rounds and divide them into 4 different segregated groups. Then I will take the powder charges suggested for our Green Dot with this out of Lyman's 3rd edition. We have a minimum of 11.5 grains, working all the way up to 15.5 grains. So I will divide the differences between 11.5 and 15.5, starting with 1 load at the very bottom, 1 load at the top, and 2 in between. Since we're working with fast-burning powders that will always work within low pressures, using a maximum load, along with caution of course, is a fairly safe practice, although always check for pressure signs as you're shooting. This allows me, on the initial test for the powder and the bullet, to get a good feel for the entire range of powders suggested. Once I like a particular load somewhere along this range, then I will start again. And let's say I like a powder charge at 13 grains. Then I can create 4 different new batches at varying degrees under and over 13 grains. Eventually, you can use this method to continually work around a certain number and tinker around with it until you find a load that you like, recoil-wise, accuracy-wise, and otherwise. And for future projects, I might as well mention that in some cases, like in our large 335 grain Lyman bullet for our same cartridge, that there may be good, well-established book data for the slower burning powders. However, there is no information on the faster burning powders, and when using a much heavier bullet than suggested for a certain range of powders, when I eventually get to this, I'm going to have to work extremely carefully. If there isn't information or using heavier bullets with a faster burning powder, you're simply going to have to fumble around in the dark in many cases. Ask people for advice and start at much lower loads than your lighter bullets, and be prepared, as always, when experimenting with new cast rifle rounds. Always check for a squib after a round. It's very important that in some cases that as we load down that we don't plug a barrel and send a new bullet after it. Same thing with my experience with a Lee Maximum 8mm. There is very little data on it. In some cases, you're going to be wandering around in the dark. In such cases, it's always important to be looking at primers and looking for other pressure signs in our cartridges as we work up loads, and always watch for squibs. So when going into uncharted territory, which we won't be dealing with in this particular project, it's worth it to note that a chronograph is a good thing to have because it allows us to measure our performance of our bullets against listed data. And when we have no listed data, it's important to understand where velocity is in conjunction with our cartridge case space, as well as everything else, to make sure that we're not shooting overpressured rounds. One sign of too much pressure is oftentimes if we're shooting a softer bullet without a coating, they will start to have severe leading before there will be severe pressure problems. So that can be one sign of building pressure if velocity cannot be linked to heavy leading. Some final thoughts on the project and working up light lead loads in general is that this is something that takes an extreme amount of patience. Differences in your lead alloys from whoever you buy your bullets from or how you cast them can cause your results to differ greatly. We can get anything from shooting an MOA from our cheap pistol powder rounds all the way to shooting bigger and bigger groups, and eventually even flyers that can be shooting 2-3 feet at 100 yards. It's a game of slowly working up loads, careful observation and note-taking, and always look at your barrel for leading, always check for accuracy, always have a chronograph if you have one, and consistently check your results. Consistency is accuracy, and this is something where you expect failure. If you have some rounds that are absolutely tumbling at 50 yards, that's part of the game. You always want to make sure that you know the size of your barrel and grooves, so that way you always have a proper sized bullet. If you do not have a proper sized bullet, the rest of your load working will do no good, because without proper obturation, nothing else matters. And as a general rule, when working with light loads and fast burning powders, it's important to remember that lighter loads and lower velocity tend to create better accuracy with these powders. Softer lead will work with these loads, and in our particular project, with our cut gas check, the cut heel for the gas check, these bullets may work well for our project, since my goal is to create a very light shooting round. Some of those bullets will work without the gas check at low pressure and low velocity. So some of the more powerful rounds during this project using these faster powders will not be absolutely representative of very hard cast bullets with plain bases, or a proper bullet such as we're using with a gas check. Take notes and try to figure out why a bullet worked or didn't work. Sometimes it's the powder, sometimes it's a gas check, sometimes it's a plain base can do better than you can expect, sometimes it's lead hardness, sometimes it can even be the lubrication we use and how we size the bullet. So as we work carefully through, keep notes and try to learn a few things. As well as having a chronograph, a good bench rest system is also very good. Try, when it comes to these loads, when we're trying to work up a load, we're trying to isolate the load scientifically. We're not trying to test how good you are as a shot, we're trying to test how well the round is. So a big heavy lead sled, or the best, heaviest setup you can build. If you're not a very good shot personally and you want to work up these rounds, don't be embarrassed to find somebody who can bench rest shoot better than you. because if we're trying to isolate why these things are working, we can't get good enough shots. Another issue in working up loads is, especially with large capacity rifle cartridges such as the 4570 Government and the 375 H&H, which we're working on, is that when using fast burning pistol powders and shotgun powders, that there is obviously a huge amount of case space that goes unfilled. This means that with movement of the bullet, powder dispersion throughout the case is going to be uneven, which could lead to erratic ignition and erratic velocities and erratic accuracy. In fact, in the Lyman 3rd edition, you will find that fillers are suggested for unique loads with 4570 Government, and you'll find others that will use such in other large capacity rifle rounds. Some are not suggested at all. There has been some controversy as the fact that some bottleneck cartridges with a much greater neck to them will sometimes have Dacron and other fillers hit the neck and cause a pressure spike. So in straight cases, filler is a much better idea. In bottleneck, it's probably best to shy away. There is an issue with this project because we are using very small powder charges in a very large case in our big Safari cartridge. However, testing I've done shows that there can actually be very close standard deviations of velocity with these powders, even without filler. Other people have done testing, and some say that the filler makes a better cartridge, loaded cartridge. Others would disagree. Others have complained of pressure spikes. So if you are going to use fillers, be very cautious. Use them only when they're recommended. Use them carefully. And again, it's about working up a load. So test. Try one with, try one without, and see the results. This is all about experimentation and learning. You have to realize every single barrel and every single gun is different. So the only way to learn is by doing. And for cast bullets, a small amount of belling or flaring will be necessary. If you do not bell and you have a properly sized bullet, it will oftentimes scrape and lose mass or become undersized as it becomes squished. So belling is important versus the usual bottleneck of using jacketed bullets. So that's another consideration. Try not to bell or flare more than you need to. You can hurt your cases. You can absolutely destroy them in some cases. I've tried the Lee Universal beller and didn't like it. And instead I bought an RCBS one made specifically for the cartridge, and it works very well. When it comes to crimping, you may want to crimp as very little as possible. Sometimes if the flaring can actually interfere with the chamber of the gun, and sometimes we cannot avoid doing some amount of crimp. If you can get away with it, many black powder shooters will actually recommend not crimping at all. So if you're having accuracy problems, make sure that your flaring is correct. If you're scraping bullets, then the rest of your nothing else that you change will fix the problem.